All right, here's a example of two lines that intersect. They give you the coordinates of the origin. They'll probably give you something like this on a test, like point A and point B. You got to calculate the angle, and they'll give you they'll give you the coordinates of these 2 points, and you just subtract for your x dimension here. And there is a formula that's very long. I never did follow it. It was in the book. So this is just a simpler version of how you would figure this out without a formula. So you need the x, and you just do that by subtraction. I guess this is 20 plus 35 would be actually, that's not the right coordinate. 75, 55, right? All right. There you go. So that's better. Then 5 is up. So this could even be longer. You just need to figure out if it was 30 degrees here, and it was, let's say, down another 5 more feet, the distance here. You could calculate the height, right? Because you'd have the coordinate of A and the B. You could calculate so this, let's just say this was running wild, right? I'm not sure this was on the test or I remember it, right? But you get the coordinate of this, and then you just got to figure out what's the distance, the y dimension, the difference in y between this one and this one, and then you have the angle, so you can calculate the x, and then you just get this 35 degree, the dimension between the two. But for simplicity, I think actually I took an exam and it was actually on the same line, so maybe it was LSIT. Hope it's not the same dimensions, same coordinates. So we need to weight these. Forget the formulas. The ratio between the tangent to this one and the tangent to this one. There is a ratio. The ratio will be the same all the way around, right? So the lengths will have the same ratio here as they do here and here, right? So let's do this. So the tangent of 50, tools, calculator. So the tangent of this, tangent of 50 divided by tangent of 30. Because let's see, copy that. Oh yeah, I did it up here. So you do the calculation, and you get this, right? Tangent of 50 divided by tangent of 30, you get 2.6. So the ratio of this tangent to this tangent is 1 to 2.0642, or 2.0642 to 1. So this is going to be 2.0642 times as big as this one. This one here will be 2.0642 times bigger. If you multiplied 11, just do it, because I'm not sure. 11.4 times 2.042, and we'll get 23, right? 23.577, 2578. So that's why this works, right? So Control Z. We need to solve for this, right? So what happens is the ratio of this 35 to the ratio is going to be the same from the 35 to the whole, which was what if you added those two together, 2.0642. Let's do that. 2.0642 plus 1. That's the whole length of what I just showed you. Let's copy that, Control C. And then if we take 35, so let's take 35 divided by that. So 35 divided by, we'll put that in parentheses. Control C. Compute 11.422, right? And that's what we wanted. We want the ratio of whichever leg was 1, right? That's it, 11.422. And that's how you do that. And then it's just simple math. You just subtract 11.422 from 55. 43.578. So if we put a point there, the x coordinate will be 51. So this isn't in the coordinates. Let's see where we got this. So x, control A, control H, enter, and then point relative to the origin will go 5 to 20, tab 5. Didn't move. Control A, control H, there, enter. Now go do that. In there, go 20, tab 5. Let's see if the mathematics is correct. So this one, we say 43.577. Control V. Tool calculator. Control V, enter. 43.577578. All right. So that's how you get the x, and then you just do your control R, tool, calculator, x, or this height over this will be the tangent of that. So h over that would be tangent of 50 times 11.42. 50 times 11.4222, enter, and you get 13.6142. 6124, right? You get this 6142, right? 6 is rounding up to 3, which is kind of odd. I don't know, but that's how you get that coordinate. So you just add that to 5. So you end up with 18.613 t. Three, and then t. It was I didn't write it down, did I? All right. Control R, just another way to figure this out. Let's check that, make sure that that's right. 43.577, 18.613. There we go. So that's how you solve for that coordinate. And it's not too hard, pretty quick. It probably takes longer to explain it for sure, but trying to explain the steps too. And show you this, right? Let's go dimension units. What I'm trying to show you is how we scale this down, why it's the same. Dimension units. We take that and make that 1. This becomes 115, enter. That's 2.0642. So the ratio of 35, if this was 35 to 3.064, that's why that works. And that's the 2.064 plus the 1. That's the ratio, right? And then what we want is the 1. So we're just taking basically 1 and multiplying it by that 11.422 factor. It becomes 11.422. Hope that helps you understand. This did come up in one of the exams. I think it was the LSIT exam. And, I'm not sure how I figured it out, but I'm pretty confident that I didn't miss any of these geometry problems. All right. Hope that helps you. Thanks for watching.